Well then, good afternoon, everybody. I hope that after the coffee break, you have still some attention. I hope you don't fall asleep. So let's go into the work. Now I'm going to present this work that we did in the 6G OpenSec project. It was a national project. That is focused on, or it's called on enforcing security for packet optical transport across untrusted multi-stakeholder domains. Essentially, I will follow the traditional structure in which I will introduce a bit the objective, the solution, the work that we did, how our solution works with and then the experience. I don't know.
Audio seems to be cutting. Is it? Yep.
Was it me who went away?
Probably because you were cutting
Yeah.
audio
Okay.
at
Well,
some point.
I hope. Unfortunately, today I had to update my laptop into Windows 11, so I hope my laptop doesn't do anything weird. I'm sorry if it happens. Anyway, what I was saying, I will just present the experimental validation with the scenario results and the demo that we did. I have some video, but I prefer to show some snapshots. But if you want later, I can also show a video. And the conclusions for the work related to this topic. Essentially, in terms of interaction and our solution, the idea is that well, we brought us what we think that it could be a 6G solution, okay, for transport networks, in which we integrate the use of DLT, distributed ledger technologies, the use of closed loops, and we bring trust-based security management across multi-domain and multi-provider environments. Okay, so the proposed solution is designed to improve the end-to-end service security by enabling an operator to interact with as many providers as possible across all the domains. Okay, so the idea is, as you can see in the picture, we have one operator, and it's not just that this operator relies on 2 or 3 specific security providers, but they have many options, each one with its own strength, based on the domain that the service or set of security resources are needed. Okay, so the idea is to accomplish this. What we did was to design this solution that it's in the OpenSec project, and that joins what I was saying, the use of blockchain-based smart contracts, okay, in order to define what we call it an offer. Okay, later I will present more details, but essentially it's the operator based on the verticals, based on the end-to-end service that the operator wants to deploy, generates a smart contract offer into the DLT where all the security providers are registered and they will receive these offers. Okay, so and then they can say if they want to fulfill this offer or not. Also, DLT is used to store and register the provider level of trust metrics. Okay, this is the value that we use to evaluate each provider and see how trustworthy is that provider. Then the other elements that are key are the use of SSLAs and TSLAs, where the operator defines the security and trust requirements, and the providers need to or will see what the operator wants and see if they can accomplish it or not. This solution also brings some real-time monitoring and automatic mitigation actions via the closed loops. So the operator will deploy a service. Okay, we request the specific service in each domain. The security providers will deliver the necessary security resources to protect that service. But they need to monitor their own service, and the operator, of course, it's not, hey, here you have, give me this and I'll complete the task. The operator also makes use of an end-to-end closed loop to monitor how the security providers perform. And finally, we use some AI-driven analytics for the threat detection and the mitigation to support robust security. Then this solution, essentially, as you can see, it's divided. It's the same on the end-to-end side, on the right side of your image, of the architecture, and on the domain. There are small differences, okay, but the idea conceptually is more or less the same. Is quite the same. It's based on two pillars, what we call the trust pillar and the security. On the security side, there is an orchestrator of slices or services, okay, the SSLA and policies manager, and the security closed loop automation on both sides. And then on the trust side, we have the trust controller. Essentially, takes care to control if from the end-to-end point of view, all the providers are accomplishing the trust SSLA requirements, and the end-to-end security closed loop does the same for the SSLAs. Then we have the TSLA policy manager and the PDL service manager, which is the gateway to the blockchain. Okay. Then what's the relation with this solution with the open source solutions that we are sharing all here? Essentially, on the domain side, we have the NFV orchestrator, which could be OSM, or the SDN controller as Teraflow, which is at the end of the experimental part. I will show you that essentially we work with Teraflow. Then, what's the part of the DLT? The DLT is capable. Well, it allows us to create a match. We needed a DLT that was capable or is capable to create and manage permissioned networks. So we don't want to have it to have a public network. We want to constrain who is able to participate. We also need a DLT that is able to make use of smart contracts. So we place a piece of code into the DLT, and whenever there is a condition that is triggered, that the smart contract activates the associated function to that condition and distributes the events across the DLT. And as I was saying, we need a DLT that is able to warn the providers using events. Okay. Here in this picture, I show you the initial part of the contract that we used in our solution. And essentially, we have three elements. On one side, we have the provider element on top. So providers can join to the DLT, and like these operators can see which providers there are. There are the offers. This is the element from the operator side. So one operator will register an offer with the SSLAs and the source and destination and so on towards the connectivity service, for example, that might need. And finally, the information, despite it says TSLA, but it was used for both TSLA and SSLAs to register the needs and what a provider is capable to offer to the operator. And finally, the service, the level of trust parameters that is constantly updated. Okay. Then, regarding this last value, what is a level of trust? I guess maybe some of you might know it, but let me introduce it. Essentially, it's the value that is identified. There are different versions. Okay, we will present ours. In our case, it's simply a value that evaluates how trustworthy is a service and a provider. In the case of the service, how it is computed is based on how the service performs. So it's continually monitored, and based on the service, the level of trust will be more positive or less. In the case of the provider, so one level above, it's computed based on how the different service lots, level of trust, but also if the providers are able to enforce the security that is expected. So it's not only if the service that the provider is delivering, but also if the provider is able to react towards an attack. If the operator sees that in one domain, one piece of its end-to-end service, there is an attack and the service is not performing well, we have a problem, because then it means that the provider was not able to hide this attack and solve it before the operator realizes. So in this case, the system will penalize the provider. Regarding this penalize or the provider is what I was saying. On one side, we award if all the providers were working well, we always award. Okay, as trust in real life. If somebody does the action that you expect well, you will trust and you will give. We don't work with values, but in this case, we are in a telco system, so we need parameters, we need values. But in this idea is, okay, you perform well, I give you a plus 10% up until to a value of 100. 100 is the maximum, 0 is the minimum. Then we have two kinds of penalties. A small penalty in terms of that we were punishing the providers in 1 or 2% over their value. That this is applied once when the operator detects that something is failing, but okay, the service still is secure. So, okay, I penalize you. But then the strong one, the real penalty is when the operator realizes that the service is not secure anymore. An attack is affecting its performance, and the provider is not performing what was expected from it. So we apply a 10%. Then the other element that we make use is the use of closed loops. I guess that most of you also know the theory. We have essentially 4 main phases, okay, in which we have the observation, we gather data, we analyze this data. Based on this analysis, there is a decision, okay, and based on this decision, we decide not only what is happening, but also how to mitigate what is happening. And of course, among all of these 4 phases, there is the data that is being shared. What do we do here? We apply this concept at 2 levels. As I was saying, at the end-to-end, so the operator is on top, on the end-to-end, and on each domain for each provider. So the operator is running on the operator side. There is an end-to-end closed loop running, but on each provider there is also an individual domain closed loop. So they are monitoring their own security service, not the operator services. This is done by the operator. It's out of the scope, but their own security network functions, for example. And they have to control that they are properly performing. And if there is a problem, the closed loop should mitigate this problem and react and execute the right actions to correct this problem. At the end-to-end is the same idea. The operator is checking how, based on a set of predefined metrics, how each provider involved in the end-to-end service, deployed service, is securing its service. If one of them fails, then it's when we trigger the possible solution. In this case, the policy or the solution that we applied was to change the provider. And this is a very simple example that I'm showing you, in which we have an end-to-end between an edge, transport, and cloud. It's failing because there is an attack, and the end-to-end detects this provider is not protecting its service, so request a change of transport provider. So it goes from transport A to transport B in order to have the end-to-end service again working properly. Again, all the closed loops are independent, so the operator is not inside the closed loop of the of the provider, because the provider has its own data and in terms of privacy, okay, and neither the providers go up to the operator to keep the privacy of each one. Following what? Sorry, now. How does our solution work? Here I will present some workflows. Okay, I will do an overview. I will not present all the details because otherwise we could be longer. But essentially, I will present the key actions and the key workflows, which the first part is the resources and smart contract based offer onboarding. Okay, the first part is that the providers they register themselves and upload the resources into the controllers and the OpenSec solution, okay? And especially in the OpenSec solution, what they do is they upload the SSLA and TSLA capabilities that they are able to offer and register themselves into the DLT. Then on the side of the operator, it uploads the end-to-end policies, service level specifications, another domain OpenSec, this is an action, the requirements that it needs, and the network slice templates, okay? Once we have all this information, essentially it's when the real work comes. In this case is when the operator needs to identify who is able to deliver the security to its end-to-end services. So what it does is, okay, selects then the network slice template that wants to protect. Okay, here there is a lot of processing in terms of identifying the different domains composing the network slice template, which capabilities per domain need to be assigned, and so on. And for each domain, creates an offer and it's uploading to the DLT. This offer then is shared to all the providers, that then they are able to decide if they can fulfill what is expected in that offer or not. So imagine that we have an offer, okay, and at the end it's a set of providers, a set of shops that are, well, that's the idea, that they are able to, hey, I have this capacity, choose me if you think that I'm the right option, okay? So then when the offer is complete, from the operator side will be kind of a menu. The operator will be able to choose which provider wants in each time. It's not exactly like this. It's a system who chooses, but I'm trying to do an easy example. The idea is here. That's the idea that we have the band, we distribute, the providers join based on if they're able or not to the offer. Then once all the offers are ready, it's when the operator needs to deploy a service, okay, request to the system to deploy the service, and essentially it creates the network slice instance creation and selects the providers. The providers are selected by the system itself based on the level of trust in that moment, the level of trust value that they have in that moment. So the ones that have the higher level of trust will be selected. Then we identify the requirements, and for each requirement, based on the selected providers, the specific request will be sent to the specific provider. So if on domain A, if in the edge domain A, the provider is selected, that one will receive the request to protect the service. Otherwise, it will be the provider B. Once everything, the network slice, the network service, the network security functions, and the security proof are deployed, then in each domain, the closed loop is configured by each provider. So the provider A will configure, will trigger the creation of the closed loop to monitor its own network security function. Once all the closed loops are done, it's when the operator is informed about, hey, all the providers are ready, and they are registered into the DLT. And finally, the operator, once all the providers are ready and registered, the provider is able to deploy, to trigger, and configure the end-to-end closed loop, because the operator already knows which providers need to monitor for that end-to-end service. Regarding the closed loop, again, our focus in this case was the end-to-end closed loop, the change of providers, and see how we can continually change the providers when they are not fulfilling their expectation. So why do I say this? Because on the side of the domain closed loop, okay, it's essentially we proceed with the theory that I explained before. The data is gathered, is analyzed, and in case the provider is able to solve the problem, the domain closed loop fixes everything, and we will then enter into the end-to-end closed. Well, sorry, the end-to-end closed loop will detect that everything is okay. But if in a second iteration, for example, that this closed loop, the domain closed loop didn't solve this attack, it's when maybe the operator will detect that, hey, you're having an attack, you didn't solve it because I'm detecting it. So it's when the end-to-end closed loop enters into action, analyzes the information, computes and decides that needs to change the provider. And what happens when we need to change the provider? Essentially computes the level of task management for the failed provider, updates this information, the level of task for the provider, and retrieves the possible new providers to substitute the failed one. The new one is selected, and then it's when it's when the failed provider is terminated. Let's say we request that provider to terminate everything, the network security function, the closed loop associated, and security proof. And in parallel, we request the new provider to deploy exactly what is expected, the network security function, closed loop, and so on. And finally, of course, as there might be other domains affected by this change of provider, we send the information to them for them to reconfigure. And at this point, it's when everything is again on track. In terms of the level of task management, what do we do? Quite similar to a bit to the closed loop, in the sense that we gather some metrics, okay? But based on these metrics, on the domain side, the task controller computes the new level of task for that service, sends this service level of task up to the DLT, which shares it with the end-to-end. It's at the end-to-end that the new provider lot, based on this service lot, is computed, updated into the DLT, and it's computed again, updated, and then the new value is updated inside the DLT for further provider selections. Then the last, or I think it's almost the last part, but or pre-last part, the experimental value actions that we did. Sorry. Here you can see the architecture of our demonstration, what we develop. Okay, in our testbed we had 9 servers. In all of them we had we were using Teraflow, okay, for the connectivity service among them, and we were emulating on two IP domain based two IP based domains, okay, on the edge and on the cloud, and one optical domain. In each domain we had two different providers, okay, for simplicity. The idea is that we were triggering, when we were doing the demo and so on, we were attacking each one of these transport providers, okay, one by one, to see how the end-to-end closed loop performs. So the change of provider was done automatically using the end-to-end closed loop, and also how the provider level of trust were updated continuously. To see this, here I present you the graphic, the graphic user interface that we used in our demo, okay? In this case, we have the topology that I was presenting before. From the this is seen from the operator point of view, let's say. So we see the different nodes below, okay? So sorry, here you can see this network, it's this topology here. On one side, we were able to control, to deploy a slice, okay, to terminate it, but especially to trigger the attacks by selecting each node whenever we wanted to emulate the scenario. We were able to, of course, to update topology, but the other important part, aside of the topology, is that here we had the list of level of trust, and as you can see at the beginning, when there's no service deployed, nothing done, all of them started with the maximum value. So all of them were trusted. They could be trusted with a 100 value. Then in that moment, we started a slice. Okay, in this case, the session was random because all of them had the same value. Okay, and this was the path. So from Edge 01, Edge IP 01, Optical 02, Cloud IP 01, and Cloud 01. I'm sorry if you don't see perfectly the names. Here, as you can see, once we already selected the system selected this path, okay, we were already monitoring the provider level of trust. And as you can see, Optical 01 already had already at that moment had a small punishment of 2%. Optical 01 is this node here in the middle, okay, and this means that maybe something was missing, but it was easily and resolved, or more than easily resolved in a fast way. But what happens when we attack? When we attack, okay, in this case we attack Cloud IP 01, okay, the system was changing, was selecting the next trustable transport on that domain. And on the level of trust side, okay, the Cloud IP, which was the one that was attacked, suffer a penalty of 10%, more or less. Think that it's 85.5 here. There were other small penalties in this one. Okay, then if we do the same for this one, for Optical 01, again, Optical 01 is punished with a 10% more or less. Before it was a 98, now it's 88.2. And Optical 02, again, when it was selected, is the green node under. When it was selected, also it was doing some penalties, but it had some mistakes or some errors, but they were solved. So the penalty was low. And finally, the same for the Edge IP 01. Okay, when it was attacked, the Edge IP 02 was selected through the end-to-end closed loop, and the penalty was also applied to this. Here, Edge IP, it's here, Edge IP with a 90%. Here, well, I didn't show you. I can show you later in the video if there is time, and you want it. But at the end, once all the service, we terminate the slice, okay, all those nodes that were performing well, then they receive a prize, as I was saying, an award. In this case, as we had Optical 02, that was in the middle and had a 90% level of trust already, when we terminated this slice, this 98% was upgraded up to 100. So it was completely trustable again. In terms of experimental results.
Sorry. We should wrap up soon. You're 5 minutes over.
Yeah, I have 3 or 4 more slides. I will go quite fast.
Thanks.
Essentially, In terms of trust, all the end-to-end actions to get the providers, forward the request, the level of trust calculations, they were done in around 81 seconds, approximately. Okay, so our solution was quite agile, despite we're using a DLT that usually is considered to have a bottleneck in terms of time. In terms of the level of trust evolution, you can see here how, okay, everybody starts at 100, but when there is a mistake, they are decreased, and and then one provider is stopped and another one begins. Okay, this time is the time that maybe we needed to change from one provider to another and activate their level of trust monitoring. In terms or on the side of the security, again, all the process to deploy and to translate from the end-to-end security and trust capabilities to the domains, they were done in less than 2 minutes. Okay. And in terms of responsiveness for the end-to-end closed loops and the domain closed loops, as you can see, we're dealing with a range of 5 to 7 seconds, more or less. So we consider that the React responsiveness was quite good. And finally, in terms of conclusions and future work, we believe that our solution brings a 6G vision in terms that it enables a new paradigm of network management with the multi-providers domain, the multi-stakeholder scenario, let's say, focus on sustainability, security, and trusted orchestration. We propose a solution that builds trust-based continuous relationships, so between operators and providers. So as I was saying, when a provider fails, the operator or the system automatically delivers a new provider to the operator. But when they perform well, they are awarded. Operators remain agnostic to security providers. They are not favoring one or the other. In terms of innovation, we believe that we are integrating some cutting-edge technologies like DLT or the use of closed loops together with the intention of the use of Teraflow. And we believe that this solution might open new path for the management orchestration systems, and essentially, especially in security, that is what we focus on. And regarding future work, we have some more idea that we can improve our solution with some advanced models to compute the level of trust parameters, some conflict detection resolutions for the multi-service coexistence, because right now we were always emulating one single service, okay? And the use or the exploration of intent-based approaches to simplify the requests. And that's all from my side. I'm sorry if I